Good evening, pre-algebra. This is your second flipped lesson. This one is on solving strange equations. Now, really quick, I want to review that when we have an equation like this, oh no, I'm not in writing mode. What am I going to do? 3x minus 4 equals, say, oh, let's make it 11. We'll make it come out nice and pretty. All right, when I go to solve an equation like this, I'm going to ask myself the questions. What's my goal? To get x alone in this case, to get the variable alone always. What numbers are keeping x from being alone? The 3 and the 4. How are they attached? The 3 by multiplication, the 4 by subtraction. How do I undo those? To undo the multiplication, I'm going to divide. To undo the subtraction, I'm going to add. But it is important to remember that I must listen to Saddam. Yes, listen to Saddam. He tells me to undo subtraction and addition first. So to undo this minus 4, I'm going to add 4. How do I know? I use the inverse operation. Addition undoes subtraction. But if I do it to the left-hand side, I must do it to the right-hand side. Oh no, I didn't put my little sneaky guy in. There we go. All right, the 4's cancel. I get a 3x. It will equal 15. X is still not alone. It's attached, but the 3 is attached to it by multiplication. I must undo multiplication with the inverse operation, which means I must divide. And I will divide on both sides. And I will divide using a 3. Here, the 3's will cancel, turn into 1x. I don't put the 1 there. 15 divided by 3, of course, is 5. Really quickly, I can check my work. I will do the check. It is very intelligent to do the check. I do want to say that I was working with a young lady Monday night at the algebra party, Caitlin Wida, and she was checking her work and just doing things very intelligently. I was very impressed. Caitlin, nice job. All right, to check, I'm going to take the original equation, 3 times the, well, it's not actually a quantity, it's just times the 5. Where's the 5 coming from? Because when I solved my work, I came up with x equals 5, so that's why I plug it in right there for x. All right, minus 4. Well, 3 times 5 is 15. Minus 4 gives me 11. And hey, that's what I wanted it to equal. So I can pat myself on the back. I know I did a good job. All right, let's look at a couple strange equations. The rules change just a little bit when we have something like this. 2x minus 1 over 5 equals, oh, what do I want it to equal? Let's make it 4. Yeah, that'll be good. All right. Now, if you're listening to Saddam, you might be thinking you should undo the subtraction first, the minus 1. But I'm here to tell you that you can't do that. First of all, this isn't a minus 1. It's actually a 1 divided by 5. How do I know? Because that 5 is going into both the 2x. I can't find my other highlighter. There it is. And it's also going into the negative 1. So that 5's kind of mucking things up. He's holding things together. He's kind of like glue. He's being divided into the 2x and into the negative 1, or the minus 1. And so, therefore, he's in the way. I'm going to get rid of him first. How am I going to get rid of him? Well, how is he mucking things up? By division, right? So I am going to use multiplication. I'm going to multiply by 5 over 1 on the left-hand side and by 5 on the right-hand side. Please realize that 5 over 1 and 5 are the same number. I am using a fraction on the left-hand side because, fill in my blank, because there's a fraction over there. The 2x minus 1 over 5 is a fraction. Now, when I do that, the right-hand side, of course, is very simple. I get 4 times 5, and I get 20. All right. The left-hand side is actually even easier. This 5 in the numerator can cancel with this 5 in the denominator. Shoop, shoop. And that leaves me with the equation 2x minus 1 equals 20. And now you'll notice that it is nothing more than a 2-step equation. That's all it is, a 2-step equation. All right, so it looks very much like the sample problem or the warm-up problem I did at the beginning of the video. I'm going to add 1 to each side. By the way, if you want to pause and solve it on your own, that would be a smart idea. It would be a real smart idea. Go ahead and pause, solve it. I've already shown you the first step. And then we will, you can unpause it and check your answer and see the rest of my work. Okay. All right, so for those of you that paused, here's the rest of the work. I will get 2x equals, those cancel, 21. And then I will divide each side by 2. Divide each side by 2. I'm doing the questions in my head, by the way. I don't want to bore you every time. All right. When I do that, these 2's will cancel, and I'll be left with x equal to half of 21. Let me see. 20 divided by 2 would equal 10, right? And 22 divided by 2 would equal 11. Well, 21 smack dab in the middle. That must equal 10.5. By the way, I saw Caitlin Weeda doing it. That's one of the reasons I'm so proud of her. All right, x is 10.5. Good. And then, of course, we can check it. We can plug it back in. All right, I'm not going to check it at the moment because I am running out of time, but I am going to look at another strange equation. This time, 3x plus 2 equals 5x minus 6. This looks like a strange equation because you have variables on both sides. That bothers you, doesn't it? Yeah, it bothers me. You know what? I'm going to take one of the variables away. Please understand that does not mean I can just simply rewrite it without one of the variables. I am going to take one of the variables away. You learned way back in first grade what take away means. It means to subtract. So I'm going to subtract a 3x from both sides. Notice, please, that I line up my x's. I line them up when I'm subtracting. These cancel, leaving my left-hand side with a 2. Leaving my right-hand side with a 2x minus 6. Well, now it's just a two-step equation. That's all it is. If you want to stop and solve it, go right ahead. Unpause when you're ready to see my work. I'll add 6 to each side. 2x, because those canceled, equals 8. I'll divide each side by 2. Divide each side by 2. Those will cancel, leaving me with an x equal to 4. If I check that, that certainly will work. All right, so what did we review? We saw that when we had an equation where we kind of had a denominator mucking things up, that to get that problem started, we needed to multiply first before we went to the questions and used the dom. What do we multiply by? We multiply by what's mucking things up, the 3, the denominator, okay? And then we also saw an example of when we have variables on both sides. And in that case, we learned that the first step was going to be to subtract off one of the variables. Now I encourage you to watch this again. Tomorrow in class we'll get some practice with this. All right, I'm trying to keep the lessons nice and short so that you can take it in small doses and become a master at this stuff. I'm really excited, guys, because most of you are in pre-algebra not because you're stupid, but because you've been unsuccessful in math before. These videos, your work ethic, believing in yourself, this is all going to change. You're going to start to have some success. Some of you already have. Kareem, for example. Janie. You're doing better work than you've ever done. Jamie Farr is doing excellent work. I don't want to leave anybody out. I don't want to slight anybody. Ryan Hevesy is doing wonderful work. Some of you are being highly successful. Watch the videos. Watch them more than once. Come in ready to do some work and get some practice with the safety net of having me in the room. All right, this is Mr. Lawrence signing off. We'll see you tomorrow, pre-algebra.